I'm first breaking down these. So with the subnet mask of 255.255.255.0. So 1, 2, 3, 4, 5, 6, 7, 8. This is the first one. Then we have a dot. Then 1, 2, 3, 4, 5, 6, 7, 8. Second dot. 1, 2, 3, 4, 5, 6, 7, 8. Third, and then we have all 0. 1, 2, 3, 4, 5, 6, 7, 8. So that refers to these things. So by default this is class C. So already we know these 24 bits are representing the network, and these 8 are representing the host. Host means the computers on the network. So now if we want to subnet this IP address further, want to break that class boundaries, that classful thing. So normally we start subnetting in the host portion. Already this is the network portion. We can't do anything here, right? Nothing can be done here with regards to subnetting. We will start here in this particular section. So what we will do, our example is perform 1-bit subnetting. So here we need to perform 1 bit. So we will move that 1 bit, this one, the nearest bit, this one, to the network portion. Means we need to on that bit. That bit will be on. So how we will find out that, or how we will perform that thing? So the first question was, how many subnet? That was the first question. If you move this right there, how many subnet? This is question 1. So this is our question number 1. So here how many subnet? To calculate that, we have a formula 2 power x. So 2 power x will give you the required answer, where the x means number of bits borrowed. Borrowed means as we move that bits towards the network, so from where we move it, from the host portion, so that we are borrowing this bit. So at the moment we are borrowing 1 bit. So what will be the value of x in this example? What will be the value of this variable if we are borrowing 1 bit? No, how it will be 2? I'm asking about the bits value. I'm borrowing 1 bits. So what will be the value of x? I'm asking about the value of x. It's simple. As we are doing 1 bit subnetting, only 1 bit. 1, 2, 3, 4, 5, 6, 7, 8. So now we are borrowing 1 bit towards the network portion. So we are borrowing this bit, this one. it will become 1. So here the x value will be 1. So we will put that right there. So 2 power 1 will result what? 2. So it means if we borrow 1 bit or if we perform 1 bit subnetting, it will divide the IP address into two different networks, into two custom subnetworks. So our first question is solved. Now the second one, this is the second. How many valid hosts per subnet are available? Means in each subnet how many IP address we can assign to computers. So for the question 1, we have the formula 2 power x, where x is equal to number of bits borrowed from which portion? From host portion of the IP. Now for the second question, this one, we have the formula of 2 power y minus 2, where the y variable means, it means that number of remaining bits in host portion. That is the value of y, and we will put that in the y. So move back again here. How many bits are left if we borrow 1 bit from the 8? Let's say this is bit 1, this is bit 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. So we borrow this 1 bit. So how many are left in the host portion now? 7. So now we will put that value into this, into the y. So in our example, the value of y is now 2. So 2 power y means 2 power 2 minus 2. What will be the result? 2 power 2. 4 minus 2. So it's not 2, it's 7. The remaining bits are 7, not 2. No, the network, the host portion. How many bits are left in the host portion? Yeah. So the y value will be 7, not 2. So 2 power 7, what will be the result? No, 2 power 7, not 2. It means 7 times 2. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiply. It is like this. 2 multiplied by 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 2. 1, 2, 3, 4, 5, 6, 7. So if you multiply that 7 times, so it will be 128. So what will be the final result? 128 minus 2, 126. So it means that in one subnet we can assign 126 IP addresses to computer. It means that 126 computer can be assigned an IP address. So here the thing. Yes. Yeah, once you practice that, it will become easier. address. Yeah, yeah. Yeah, yeah. So you are learning the math, and once you learn the math, then you will perform such thing. Depend on the organization thing, whether you need 1 bit subnetting, whether you need 2 bit subnetting, whether you need 3 bit, 4 bit, 5 bit, and so on. That's just learning the basics, and then you will apply that in the real world as per your requirements. Yeah, yeah. First, you need to calculate. Once you have practice and learn it, then it becomes much easier. Like I'm now doing in my student life, I also in initially once I looking was towards the teacher, so I'm just looking towards him and thinking what he's doing. But once you practice, once you perform those different example, then it become much easier. No, no, that's just giving you a simple example how we can perform. Well, in the real world, you may perform 3 bits, maybe you may perform 4 bits, or sometime you may perform 5 bits. Okay, 3 bits, 4 bits, 5 bits, or maybe 2 bit subnetting. Depend. And there is another thing. Uh, you may heard it or not. There is another thing VLSM, but it's out of the scope at the moment. Variable length subnet mask. So plenty of there, but as you know, there are different levels. So just at the moment, keep focus on the subnetting. So we have resolved 2 questions. We resolve question number 1, and we resolve, yeah, so we resolve that 2 subnets can be created, and in each subnet we can give total of 126 IP addresses. Means 126 computers can be connected in that one subnet. Now comes in, forget this question, moves to this question, the fourth one. So then it says the broadcast address. So the broadcast address means the last address in a subnet. It will be the last address in a subnet of a IP address. So how we will calculate? It's pretty simple. Let's say my first subnet will be 192.168.0.0. Now, as I'm performing 1 bit subnetting, and already it was 24/24, so now we will add a 1 to 24. So what it will become if we add 1? So it will become 25. Already it is 24 bits. Class C address have 24 bits for the network. So now we add 1 more. So what will be the value? It is 25. You can see here. Okay, so here we will write /25. So the first address that can be assigned to a computer is 192 192.168.0.1, and then the second address 192.168.0.2, and so on. So how many assignable address we can have? We figure out that as well. So the last address will be what? If we start from 1 and moving further, so the last assignable address that can be assigned to a host, a computer on the network, will be what? What I will write here? 126. Very good. So you can see that this is the range that we can configure. And now comes in this question, what's the broadcast address? So as I said, the last address in a subnet. So the last address in a subnet is 192.168.0.127. So this is the broadcast for the first subnet. This is the broadcast, and this is our first subnet. Now calculate the second one. You need to calculate the second subnet. As we know, we can create two subnets. So the first subnet is done. This is the first subnet. We write it down. Now you need to write down the second subnet. So from which address we will start? Let me write 192.168 dot, what should I write here? 0 dot what? 1 28/25. This is the address of the second subnet, because here the first subnet end right here. So the next number is 128. So that will be the number of your second subnet. Then the first assignable address will be 0.129, and the last assignable will be what? Calculate it. Yeah, I'm asking question. I said, what will be the last address after 129? If you move on, 126 addresses can be assigned. So if you count 129, 130, 131, 132, reach out the 126 number. So the last assignable address will be what? No, you start from 129 and then you move on to 192.168.0.129.130 and moving on. So the last address will be 192.168.0.254. Yes. No, it's tough, you will see, but you need to know. So 254 is the last address. If you count down like that, if you add 128 and 126 with each other, so if you count 1, 6 and add 14, 2, 2, 4, 5 and 1, 1, 2, 254. So you can calculate that 254 will be the last address in this subnet, which we can assign to computer. So you can calculate it that way as well for simplicity. And what will be the broadcast? The last assignable address in this subnet is 192.16. Let me write here it is 192.168.0.255. That's subnetting for you. I will give you some will send you some example that you need to read and configure those stuff. Okay.